Today we'll be covering pages 307 and 308 of our textbook. You want to have a highlighter as well as your regular writing utensil. Unit 10, Lesson 12, Adding and Subtracting Rational Expressions. 2 guidelines for addition and subtraction of fractions. Fractions must have a common denominator. The common denominator consists of each factor, the greatest number of times it appears in the denominator. And denominators can only be changed by multiplying the overall fraction by 1. Just as if we were going to add 2 fractions like 1/2 plus 1/3, you know we need a common denominator, and that common denominator would be, in this case, 6. So we would write the common denominator of 6 and write equivalent fractions. 1/2 is equivalent to how many? 6. Well, 2 times 3 will give me 6, so we're multiplying the fraction 1/2 by 1 in the form of the fraction 3/3. That would be equivalent to 3/6 because 1 times 3 is 3. The fraction 1/3 we would multiply by 1 in the form of 2/2. 3 times 2 is 6, 1 times 2 is 2. And we end up with, now that our denominators are the same, we copy the denominator and we add 3 plus 2 and get 5/6. We want to do the same with rational expressions. Combine each of the following fractions by first finding a common denominator. We always want to express our answers in simplest form. So we'll go right to the denominators of 4x and 6x. Common denominator, we'll take the larger 6x. Does 4x go into 6x evenly? No. So the next multiple of 6x is 12x. Does 4x go into 12x? Yes. So our common denominator will be 12x. So let's write down equivalent fractions with denominators of 12x. What do we need to multiply 4x by to get 12x? 3. So we're multiplying this fraction here by 1 in the form of 3/3. 3 times 4x is 12x. 3 times 2x minus 5. Distribute is going to be 6x minus 15. What do we multiply 6x by to get 12x? We multiply by 2. So we want to multiply this entire fraction by 1 in the form of 2/2. 6x times 2 is 12x. 4x plus 2 times 2, again make sure you're multiplying each term by 2, is 8x plus 4. Same denominator, so we copy that, 12x. Now we combine like terms of the numerators. 6x plus 8x is 14x. And negative 15 and positive 4 is negative 11. Can we simplify this fraction? No. Can we factor the numerator? No. So this is our final answer in simplest form. B. Can go right to the denominators, 5x and 10. Well, 5 goes into 10, but we also need an x. So our least common denominator is 10x. We need to multiply 5x by 2 to get 10x, so we're multiplying the entire fraction here by 1 in the form of 2/2. Add in parentheses. In doing so, we have 8x minus 2. 10 times x will give us 10x, so we're multiplying this fraction by 1 in the form of x/x. X squared plus 5x. Combining like terms, and putting in standard form. So we want our x squared term first. 8x and 5x is 13x, and minus 2. Are there factors of negative 2 that sum to positive 13? No. So this is our answer. This cannot be simplified. 4x and 2x squared. Okay, so 2 goes into 4, and x squared is larger than x. So our least common denominator here is 4x squared. Multiply by x over x. We get 3x over 4x squared plus, and here multiplying by 2 over 2. 2 over 4x squared. Let's copy the denominator, 4x squared, and 3x plus 2 is our numerator. And this cannot be simplified. Each problem, exercise number 1, had monomial denominators, right? Single term denominators. If the denominators are polynomial, then factor the denominators before finding a least common denominator, right? Factor the denominators first. Combine each of the following fractions by factoring the denominators first, then find the common denominator. Write equivalent fractions with the same least common denominator, and add numerators. Simplify the result if possible. Right, so this denominator, this binomial, there's a GCF 5 that comes out. So we have 5 times y minus 3. And this is the difference of perfect squares, y plus 3 times y minus 3. Now, when we have factors for denominators, the common denominator consists of each factor the greatest number of times it appears in a denominator. In other words, so we have a 5, so each fraction, each equivalent fraction needs 5. We have a y minus 3 here, which occurs once in this denominator. It also occurs once in this denominator. So we want 1 y minus 3. And we also have a y plus 3, which occurs once here. So we need that. So all 3 of these factors make up our least common denominator. What's missing from here to get here is the y plus 3. So we need to multiply by 1 in the form of y plus 3 over y plus 3. In doing so, 4 times y plus 3 is 4y plus 12. And what's missing here, what do we multiply this by? To get to this, we're missing the 5. So we're multiplying by 1 in the form of 5 over 5. 5 times 5 is 25. Okay, we have the same denominator, so let's copy it and leave it in factored form. 5 times y minus 3 times y plus 3. Combine the like terms in the numerators. 4y plus 12 plus 25 is 37. And this cannot be simplified, so this is our answer. In B, factor the trinomial, the factors of 20 that sum to negative 9, negative 4, and negative 5. So this factors into x minus 4 times x minus 5. And the factors of positive 8 that sum to negative 6 are negative 4 and negative 2. This factors in x minus 4 times x minus 2. Now we want to write our common denominator. So x minus 4, that occurs once in each. We need that. X minus 5 occurs once here. We need that. And the x minus 2. We need that. So x minus 4 times x minus 5 times x minus 2 is our common denominator. We need x minus 2 here, so we're multiplying by x minus 2 over x minus 2. And on the other side, we're missing the x minus 5, so we're multiplying by 1 in the form of x minus 5 over x minus 5. Okay, x minus 2 times x minus 3. It's going to be the double distribution. Will leave me with the trinomial x squared minus 5x plus 6. And then 2 times x minus 5 is 2x minus 10. We have same denominator, so let's copy it and combine like terms of the numerator. X squared, negative 5x and positive 2x is negative 3x, and 6 plus negative 10 is negative 4. Now, does this trinomial factor, the factors of negative 4 that sum to negative 3 are negative 4 and 1. Now that we have a single fraction, now we need to see, can we simplify or reduce this fraction? Okay, so this is going to numerator factors into x minus 4 times x plus 1. The denominator is still our x minus 4 times x minus 5 times x minus 2. And now we see that the x minus 4s are common to numerator and denominator. They divide out. Our answer is, our simplified answer is x plus 1 over x minus 5 times x minus 2. Our next page, we have subtraction. Perform each of the following subtraction problems. Express your answers in simplest form. Okay, whenever I have subtraction, I tend to bold it. Right? Really going to bold the subtraction. And subtraction. Alright, we have same denominators here. So we can simply copy the denominator. And I'll factor it in the next step. And we are subtracting, okay? So 3x minus x is 2x. 7 minus 3 is 4. So 2x plus 4 is our numerator. Now, can we simplify our single fraction? Well, we're going to factor the numerator. GCF2 comes out. We will factor the denominator. Difference of perfect squares, x plus 2 times x minus 2. And we see that our x plus 2's divide out. So this simplifies to 2 over x minus 2. B, denominators are not the same. So we will factor our denominators. Difference of perfect squares, 2x plus 1 times 2x minus 1. GCF 5, 2x plus 1. Common denominator. We have 2x plus 1, 2x minus 1, and we need a 5. Our first fraction, we're multiplying by 1 in the form of 5 over 5. And distributing, we have 5x minus 15. our second fraction, we're multiplying by 1 in the form of 2x minus 1 over 2x minus 1. Distributing 4x minus 2. So we have our common denominator. Let's copy it. 5 times 2x plus 1 times 2x minus 1. Now we're subtracting. 5x minus 4x is x. And negative 15 minus negative 2 is going to be negative 15 plus 2, which is negative 13. And this does not simplify, so this is our answer. C, factors of our first denominator, difference of perfect squares, x plus 2 times x minus 2. And of our second denominator, the factors of negative 20 that sum to positive 8 are negative 2 and 10, and negative 2 and 10. So x plus 10 times x minus 2. Our common denominator is, we need an x plus 2, we need an x minus 2, and the x plus 10. And it's subtraction, let's really bold that. We're multiplying our first fraction by 1 in the form of x plus 10 over x plus 10. And multiplying x plus 10 times x, we get x squared plus 10x. Multiplying our second fraction by x plus 2 times x plus, by 1 in the form of x plus 2 over x plus 2. And multiplying here, we have 6x plus 12. We have our common denominator, so let's copy it, and then we combine like terms in the numerator. X squared minus, there is no other x squared term, okay. 10x minus 6x is 4x. And 0 minus 12 is negative 12. Now, can we factor this trinomial? Are there factors of negative 12 that sum to 4? Yes, 6 and negative 2. Alright, so this factors into x plus 6 times x minus 2 over our denominator of x plus 2 times x minus 2 times x plus 10. And you see that the x minus 2's divide out. So our final answer is x plus 6 over x plus 2 times x plus 10. With D, factoring 4 and 1. Factors are 32 that sum to 6, 8 and 4. Common denominator. X plus 4 times x plus 1 times x plus 8. Multiplying the first fraction by 1 in the form of x plus 8 over x plus 8. Okay, double distribution here. Right, I'm going to end up with x squared, a positive 8x, and a negative 2x combined to be a positive 6x. And 8 times negative 2 is negative 16. Second fraction we'll multiply by 1 in the form of x plus 1 over x plus 1. And we have 8x plus 8. Let's copy the denominator. Now that our fractions have the same denominator, we can just copy it. And now we have our single fraction, x squared, 6x minus 8x, 6x minus 8x, negative 2x, negative 16 minus 8, negative 24. Now, can this trinomial be factored? Are there factors of negative 24 that sum to negative 2? Negative 6 and 4. And this is equal to x minus 6 times x plus 4 over our denominator. And we see that our x plus 4s are common to numerator and denominator. They divide out. Our simplified answer, x minus 6 over x plus 1 times x plus 8. And our last question, which of the following is equivalent to? We're subtracting, okay? The common denominator here, does x divide evenly into x minus 1? No, x minus 1 is a binomial, right? So our common denominator is x minus 1 times x. These are two totally different things. Our first fraction will multiply by 1 in the form of x over x. 1 times x is x. Our second fraction will multiply by 1 in the form of x minus 1 over x minus 1. X minus 1. Copy the denominator. Now that we have a common denominator, just bring it over. Now let's subtract. X minus x is nothing, or 0. Minus a negative 1 is a positive 1. Okay, so this cannot be simplified. This is our answer, but I don't see it here because what they've done is, for the choices, they've multiplied the x times x minus 1 to get x squared minus x. Choice 3. Thank you very much for your attention.